Okay, so this is chapter 2, stress psychophysiology. So in our last lecture, we went over the stress pioneers, the definition of stress, domains of health, and how we respond to stress, as well as the stress model. And during this lecture, I will go over the physiological response to stress in more detail. So stress begins in our brain. We must perceive a situation to be stressful in order for the stress response to occur. All right, so this is our brain. We have two major components of our brain. The first, outlined in red, is the cerebral cortex, and it is responsible for thinking and cognitive functions. Our subcortex, outlined in blue, is responsible for various physiological processes that keep us alive, and I'll talk about these in more detail in the next slide. Okay, so let's talk about our cerebral cortex. So this little diagram shows the structures of the cerebral cortex, and then I just kind of have all of the lobes laid out. So our frontal lobe is responsible for reasoning, parts of speech, problem solving. The parietal lobe is responsible for movement, orientation, and perception of stimuli. Our occipital lobe, which is right here in green, is responsible for vision, and the temporal lobe is responsible for memory and speech. You don't need to memorize each one, but you should know the difference between the cerebral cortex and the subcortex. So moving on to the subcortex. So first we have our cerebellum. And our cerebellum is responsible for body movement. Our medulla oblongata, incredibly important. It regulates our heart rate, our respiration rate, and reflexes such as vomiting, coughing, sneezing, and swallowing. Then we have our pons. Our pons is responsible for our sleep cycle. It regulates our sleep cycle, which is incredibly important to our overall health. And then we have our diencephalon. So our diencephalon is composed of our thalamus and our hypothalamus. Our diencephalon regulates our emotions. And our thalamus and our hypothalamus are critical when it comes to the stress response, and I'll talk about that on this next slide. So our diencephalon, again, composed of our thalamus and our hypothalamus. So our thalamus is our brain's relay station. It relays sensory impulses from other parts of the nervous system to our cerebral cortex. And then once our cerebral cortex decides, okay, this is a stressful situation, it is going to send signals to our hypothalamus, letting it know that the stress has been detected and we need to sound the alarm. We need to get our body ready to respond to this stressor. And our hypothalamus is the primary activator of our autonomic nervous system, which is responsible for our fight or flight response. And we'll talk about that more in just a moment. And both of these structures are a part of our limbic system. And our limbic system is responsible for emotions such as fear, anxiety, and joy in response to physical or psychological stimuli. And these are integral to the stress response. As you know, going back to our stress model, emotional arousal is a part of that stress model. So emotion is very, very important when it comes to the stress response. And our limbic system is also known as the seat of emotions. Moving on to the reticular activating system, or RAS. This is a network of nerves that connect our mind and the body. And if we experience excessive arousal or excessive stress in our lives, that is going to lead to stressful responses. So we will experience the fight or flight response. And if we experience that on an extended basis, we will experience illness or disease. And then if we have on the other side of the spectrum an under-aroused cortex, if we don't get enough arousal or enough stimuli, we will experience difficulty learning, poor memory, and little self-control. So our brain and our body, we need a specific amount of arousal, a specific amount of stimulus. So we do need that stress in order to survive. So going back to that U-shaped curve that we looked at when we talked about chapter 1, we do need an optimal amount of stress in order to function appropriately. If we have too little, we will get sick. We will experience disease or illness. And then same thing if we have too much. So again, we need an optimal amount of stress in order to function optimally. Moving on to the physiological pathway of stress. So before I get started talking about the specific hormones that are released during the stress response and the physiological components that become changed, I would like to go over these homeostatic baselines. So homeostasis refers to our stable state or our resting state. So our heart rate, so our resting heart rate usually is around 60 to 100 beats per minute for those of us that are 10 years of age and older. And it can be as low as anywhere from 40 to 60 beats per minute for individuals that are well-trained athletes. The best time to check your resting heart rate is the moment after you wake up and you're still lying in bed. If you have some piece of like athletic tracking equipment, if you have an Apple Watch or if you have a Whoop device, you can actually look at your resting heart rate from your watch or from your app. But if you don't, and you would like to learn how to take your resting pulse, your resting heart rate, send me an email and I can send you just a quick little article on how to do that. But moving on to your blood pressure. So resting blood pressure is less than 120 systolic and less than 80 diastolic. That is normal. 140 over 90 is now considered to be hypertensive 2. The resting blood pressure categories have changed. So normal resting blood pressure is less than 120 and less than 80. Our serum glucose, also known as our blood glucose or our blood sugar, anywhere from 70 to 100 milligrams per deciliter, but this is also very heavily dependent on your last meal. So if you just had something to eat, chances are your blood glucose is going to be a little bit higher compared to someone who ate hours ago. So this is really dependent on the last time of your meal. And then our respiration rate, so we're taking about 12 to 16 breaths per minute. So during rest, this is our homeostatic baselines. These are our heart rate, blood pressure, serum glucose, and respiration rate at rest. And once the stress response starts, this is all going to change. Okay, so let's talk about the pathways in which stress can occur. So first, we have our autonomic nervous system. That is our immediate fight or flight response. And then we have our endocrine system. So depending on how long that stressor is in our lives for, our endocrine system can be responsible for a short or long-term stress response. And both of these are activated by our hypothalamus. Very important. Okay, so talking about the autonomic nervous system in a little bit more detail. So our autonomic nervous system is actually made up of two systems, our sympathetic nervous system and our parasympathetic nervous system. So the sympathetic and the parasympathetic, again, make up our autonomic nervous system, and they're going to work together during immediate stress. So when a stressor, when we have a stressor, we perceive that to be stressful, our sympathetic nervous system is going to turn on, and it's going to get us to fight or flee. So our body is getting ready to expend energy in order to take care of that issue that is in front of us or run away from it. And then our parasympathetic nervous system, that is our body's way of conserving energy. So once the stressor has gone away, once we have identified that, okay, now we are safe, we no longer feel threatened, the parasympathetic nervous system is going to kick in and bring us back to that level of homeostasis. So again, our autonomic nervous system functions. It is activated by the hypothalamus, and it functions by direct innervation. So our organs are innervated by parasympathetic and sympathetic nerve fibers. So when the parasympathetic nervous system kicks in, we have our sympathetic fibers that are going to get us ready to fight or flee. So our heart rate is going to increase, our intestinal secretions are going to decrease, and I'll talk about why these things specifically occur in a later slide. But depending on if our body is facing that stressor, these are some of the things that are going to occur. And once our body decides or our body perceives that, okay, that stressor is no longer an issue, then the parasympathetic is going to bring us back to homeostasis. And this functions by direct innervation. So we have those direct nerves that are going to all of those organs and muscles as well. Okay, so when our sympathetic nervous system is activated, these are the things that we are going to, well, we can't necessarily feel everything, but we can definitely feel an increase in our heart rate, because when we're getting ready to, flee or fight the stressor, our heart needs to pump more oxygenated blood to our limbs in order to, again, fight or flee. So we'll have an increase in heart rate. An increase in stroke force is the amount of blood that our heart is pushing out with each beat. So our heart is going to be pumping harder and faster and more forcefully. Our pupils are going to dilate to allow more light to get in so we can see clearly around us. Our coronary arteries are going to dilate. So our heart has its own network of blood vessels, and that's our coronary arteries. So if our heart is working hard to pump oxygenated blood to the rest of our body, it also needs a little bit more as well. Our abdominal arteries are going to constrict, and that's because this is not the time to rest and digest. This is the time to fight and or flee. So we don't have time for our body to digest any of the nutrients that are coming through our gastrointestinal tract. So our blood is going to be shunted away from our gastrointestinal tract, from our abdominal arteries in order to go elsewhere. It's going to go to our skeletal muscles. It's going to go to our heart. Any of the limbs that are being used, maybe more so to our legs in order to get away. Our bronchial tubes are going to dilate. So again, we can allow more oxygen to get in. We might feel a little bit stronger. We definitely see an increase in skeletal strength, an increase in mental activity. Your mind is sharper. You're thinking, okay, what do I need to do next in order to evade this stressor? And then we will also see an increase in basal metabolic rate, also known as an increase in your metabolism. And I'm sure some of you might have heard that, individuals during times of stress, that, they experience great feats of strength, mothers lifting cars off of small children. So, this response is tremendous. And we'll talk about specific hormones that are responsible for this response in a moment. So moving on to the endocrine system. So the endocrine system, this is various glands that secrete hormones that alter the function of bodily tissues. And we have 4 specific tissues that we're going to talk about when we talk about the endocrine system. So the adrenal medulla, the adrenal cortex, the thyroid, and the pituitary gland. So again, our adrenal glands are located right here on top of our kidneys. We're also going to talk about our pituitary gland that's located right here in the base of the brain. We're also going to talk about the thyroid located on the anterior aspect or the front aspect of your neck, just right in front of that windpipe. And of course, we have other glands that are responsible for secreting hormones, such as the testes in males, ovaries in females. But for this course, we're only going to be focusing on those 4 tissues that I previously mentioned because they are responsible for secreting those hormones in the stress response. Okay, so this is the physiological pathway of stress. You don't need to memorize this, nor am I going to describe it using this slide because I would most likely lose all of you right now at this point. I think it would be incredibly boring if I were to just kind of go through, the stressor occurs, we perceive it to be stressful through the cortex, and then, we send that information to the thalamus that relays that to the hypothalamus, and then so on and so forth. Nope, I'd lose you. So we are going to discuss this in a different manner. I've put this together in a way hopefully some of you will find entertaining and easier to understand. So in the form of theater. Okay, so Act 1. So the adrenal medulla, the cast in order of appearance. So we experience the stressor. That goes to be processed in our cerebral cortex. It gets sent to the thalamus, then relayed to the hypothalamus, and then to the posterior hypothalamus through the nerves, and then through epinephrine and norepinephrine hormone secretion. So just a reminder, this is our adrenal gland that sits right on top of our kidney. The cortex is this nice yellow, it almost looks kind of like a fatty piece of tissue. So that's on the outer edges of our adrenal gland. And then our medulla is this nice kind of pinkish colored center of our adrenal gland. And this is important. Okay. So epinephrine and norepinephrine, so the effects of epinephrine and norepinephrine last 10 times longer than adrenal corticoids. And that is tremendous. So the effects of epinephrine and norepinephrine include an increase in heart rate, an increase in stroke force, the dilation of coronary arteries, the dilation of bronchial tubes, an increase in metabolism, and then also an increase in oxygen consumption. So when we are running away from our stressor, we are going to consume more oxygen in order to supply our body with the oxygen that it needs during that period of, fighting or fleeing. And then I also want to mention that epinephrine and norepinephrine are also known as adrenaline and noradrenaline, respectively. Okay, moving on to Act 2, the adrenal cortex, the cast in order of appearance, the stressor, the cortex, thalamus, hypothalamus, anterior hypothalamus, the specific hormone releasing factor, which we're not going to get into, pituitary gland, another hormone releasing factor, the adrenal cortex, and then finally the release of cortisol and aldosterone. So these are going to be the stars of the show here. Okay, so again, just a reminder, our cortex, this nice yellow, fatty looking piece of tissue, and then our medulla is on the inside. So we have glucocorticoids and mineral corticoids. So our glucocorticoids, such as cortisol, regulates the metabolism of glucose. So cortisol is going to increase our blood glucose when it is secreted, okay? And then our mineral corticoids, such as aldosterone. Aldosterone will increase our blood pressure in preparation for action. So our mineral corticoids are actually going to regulate the balance between sodium and potassium. And it will increase our blood pressure in order to transport fuel and oxygen. So remember how I mentioned previously how epinephrine and norepinephrine, those effects last 10 times longer than corticoids. So they're gonna last 10 times longer than these hormones here. And that is tremendous. That is quite an effect on our physiology there. And I also wanna talk just a bit about cortisol. So some of you may have heard that cortisol is that specifically, air quote, that stress hormone that is responsible for causing a buildup of abdominal fat, specifically around the middle of your abdomen, around your belly button. And part of that is true, because if you experience stress for an extended period of time, your body is going to secrete blood glucose in order to keep your energy up. And as a result, this can also affect your hunger. So there is kind of a give and take when it comes to cortisol. So we see an increase in the level of cortisol, we see an increase in blood glucose, we see an increase in hunger, therefore we see an increase in appetite. So individuals tend to get a little hungrier when stressed out, but then there's also a correlation between stress eating and emotional eating. So all of that is tied to this cortisol. So cortisol can be a culprit when it comes to that weight gain, particularly around the middle of the abdomen. Okay, moving on to Act 3, the thyroid gland. So again, the cast in order of appearance, the stressor, the cortex, the thalamus, the hypothalamus, anterior hypothalamus. This is another hormone releasing factor. The pituitary gland, another hormone releasing factor. And then eventually we get to the thyroid. And then our star of the show, thyroxine, which eventually gets secreted into our bloodstream. So thyroxine. So when thyroxine gets secreted into our bloodstream, we will see an increase in our metabolism. We will see an increase in fatty acid mobilization, as well as an increase in gluconeogenesis. And gluconeogenesis is the production of glucose from amino acids by the liver. So again, when our body is getting ready to adjust to the stressor, we need more energy. And one way to get it is through gluconeogenesis. So the production of glucose from amino acids by the liver. We will experience, not everybody experiences this, but some more than others definitely, an increase in gastrointestinal motility, which is a fancy way of saying that you will experience more movement in your gastrointestinal tract, which means diarrhea. We will see an increase in respiration rate and depth. So we will be breathing more frequently, and we will be breathing a little deeper. An increase in heart rate, an increase in blood pressure, increase in anxiety, and then decreased feelings of tiredness. Moving on, the final act, the pituitary gland. So again, cast in order of appearance. Stressor, cortex, thalamus, hypothalamus, anterior hypothalamus, the pituitary gland, and then vasopressin, also known as antidiuretic hormone, oxytocin. So these two are the stars of the show in this act. Okay, so vasopressin. Again, it's also called the antidiuretic hormone, and it will increase blood pressure by increasing water retention. So it will cause your body to hold on to water, and then it will also decrease your urine production. Moving on to oxytocin. So oxytocin is a very interesting hormone. It is released during times of stress, but it is also released during times that are deemed as intimate, such as when a mother breastfeeds her baby. This is released during sex, and this is released during, times of intimate bonding. And oxytocin will cause an increase in the contraction of blood vessel walls. And when it is released together with vasopressin or that antidiuretic hormone, the body will respond with an increase in blood pressure. But researchers believe that this hormone, when it is released during stress, it is to lead those individuals to seek social support, to seek closeness in order to relieve that stress that is being experienced. Not specifically seeking relief through intimacy, but seeking social support in general. So whether you need, someone to lean on, when times are tough, or whether you need to vent to someone about the stress in your life, this is social support. And as humans, again, I've mentioned this previously, social support is incredibly important. And human beings, we are meant to be social, and we are meant to share our lives with others. And the next couple of slides here, these are just a summary. This is just a summary of the hormones and what they are responsible for. Okay, now let's talk about the effects on our body systems. So first, starting off with our cardiovascular system. So our cardiovascular system is composed of our heart and all of our blood vessels, our veins, our venules, our arteries, and our capillaries. So stress on our cardiovascular system, like we previously learned, if we get to that extended stage of chronic stress, we could see a release of oxytocin and antidiuretic hormone, which could lead to an increase in blood pressure. And then with the release of thyroxine, we will see a mobilization of cholesterol and free fatty acids. So these kind of break off and float around in our bloodstream for energy, but these can also increase the risk of heart disease. So when we experience stress, our cardiovascular system is at the greatest risk. Our heart will respond to stress with increased force of contraction. It's going to pump harder. It's going to pump more frequently. We will see an increase in blood pressure from this oxytocin and antidiuretic hormone. So that will make us more susceptible to heart attack, to stroke. But we'll talk about that in more detail when we get to chapter 3 and we talk about illness and disease. Okay, so this is something that your textbook does not mention, but I think it is very important to know. And it's something called heart rate variability, or HRV. So HRV is a measurement of the natural variation that occurs between heartbeats. And this beat-to-beat variation gives us a measurement of our autonomic nervous system. So it tells us if, during times of, stress, pain, inflammation, or illness. So if we see a high heart rate variability, these beats are less regular, we are experiencing less stress. And if we see times that we have a low HRV, that means that we are under more stress, whether that stress is real or imagined. Maybe we just sustained injury, so we are in some pain, we're experiencing inflammation, or maybe we're sick, maybe we have a flu or a cold, and our heart rate variability is going to be lower because our body is experiencing more stress, whether that is mental stress or physical stress. The data on the left-hand side of the screen here, so this is actually from my husband's Whoop device. I don't know if any of you have ever heard of Whoop, but Whoop is a popular device that is used by a lot of CrossFitters. So it looks like just a plain band that you wear, and it is connected to an app on your cell phone. And this app will track your heart rate variability, your heart rate. It'll track your breathing rate. I believe it also tracks your sleep as well. But I bring this up because my husband is typically a very low stress individual. And as you can see, he has usually a very high HRV. But you see all of a sudden on February 2nd of 2020 that this went down tremendously. And on this day, he was experiencing a significant amount of stress because on that day, if you are a football fan, on Sunday, February 2nd of 2020, the San Francisco 49ers and the Kansas City Chiefs were playing during the Super Bowl. And my husband is a big San Francisco 49ers fan, and they lost. So the entire day, the entire time he was watching this game, he was incredibly stressed out. And again, that's not like him whatsoever. So I asked him, can I see your data from your Whoop? And lo and behold, you can tell by looking at his heart rate variability that he was experiencing stress. And trust me, I was sitting there with him watching the game, and he was visibly stressed out. But this is just something that's very interesting that you can look at and you can track over time. So if you have your own Whoop device, or if you have a heart rate monitor, an Apple Watch, on your Apple Watch in the Health app, you can actually see what your heart rate variability is over time, from day to day, week to week, and then even year to year. So I think that this is incredibly interesting, and just one of the cool physiological ways that you can kind of track, the physiology of your stress. Okay, moving on to the gastrointestinal system. So our gastrointestinal system goes from our mouth all the way to our anus. So I put up a little diagram for you here on the right side of the screen. So stress can reduce saliva production and increase hydrochloric acid production. And hydrochloric acid is that acid in our stomach. And as a result, we see a decrease in saliva production, an increase specifically in that hydrochloric acid production. That increased amount of hydrochloric acid can actually cause ulcers. So again, that stress will increase the amount of hydrochloric acid in our stomach. Our blood vessels in our digestive tract constrict, and as a result, that reduces the amount of gastric mucus that lines and protects our stomach. And ulcers, these are these small fissures in the stomach wall. As a result, they could develop. So again, we will see an increase in hydrochloric acid production, and we will see a decrease in that gastric mucus that protects the lining of our stomach. And then these ulcers, start in the lining of our stomach wall. And these ulcers can become incredibly painful, and it can really have an effect on your day-to-day life, because these are just very troublesome. And then stress can also alter your peristalsis. So like I mentioned earlier with thyroxine and that increase in gastrointestinal motility, this is the same thing, but for some individuals, they may experience diarrhea, we have an increased amount of peristalsis. We have increased gastrointestinal motility. Things are moving too quickly. And some individuals might actually experience constipation. So if that peristalsis, that motility is too slow. Yeah, moving on. Okay, so moving on to the muscular system. So yes, your muscles can be affected by stress, specifically by something called bracing. So bracing is unnecessary muscular tension. I usually see a lot of bracing. Individuals tend to brace their shoulders. So you might be sitting here, taking notes. Just kind of notice how your shoulders feel. Drop them back down. Did you have to drop them down? Did they fall 3 inches? And if they did, that's okay. That's normal. But that is bracing. So unnecessary muscular tension. And if this goes on for long enough, it can lead to the development of muscle pain and aches. And I'll give you a more specific example on the next slide. And then our smooth muscles may be altered as well, just like I mentioned previously with peristalsis in our gastrointestinal tract. And then it can also affect our cardiac muscle, our heart muscle specifically. So it can lead to the death of cardiac muscle cells and then a loss of that contractility of our cardiac muscle cells. So when it comes to bracing, I ask that, just stop, take a moment, actually take a few moments throughout your day and just pay attention to how you feel. Do you feel tense in any areas of your body? Do your shoulders feel tense? What about your anywhere in your back or even in your mouth? A lot of people tend to clench their jaw. That is bracing. Again, you don't mean to do it, but it just kind of creeps up on you and it starts to happen. That is bracing. And we'll talk about how to combat bracing specifically with one of our lab activities coming up in a few weeks here. Okay, so I wanted to give you an example, a good example of how stress can affect multiple body systems at once. So here's my example. So let's say you are experiencing pain that is caused by bracing. So you are clenching your jaw unintentionally, and you're having pain up here in your temples, just all along your jawline. You're having a tension headache. And because of the pain from that tension headache, this pain has just gone on for an extended period of time. And the only thing that makes it feel better is the consumption of non-steroidal anti-inflammatory drugs. Examples of these drugs include Advil, Motrin, ibuprofen, Aleve. These are NSAIDs, again, non-steroidal anti-inflammatory drugs. So excessive consumption of NSAIDs can cause damage to that mucus lining in our gastrointestinal tract. It can be an irritant, or it can impair the barrier properties of that mucus. So it can cause injury, and it can cause the inhibition of repair when our body is attempting to repair, the breaks in that stomach lining. So damage to the lining, to that mucus, it could potentially cause ulcers. So just showing you all an example of how, one issue caused by stress could lead to another one. And maybe even one that's that's slightly more serious. So if you are someone that experiences a lot of bracing, and as a result you experience tension headaches that lead, whether it's from your temples, down your jaws, down your traps, all the way into your shoulders, there's an activity called progressive muscular relaxation, and that might be for you. And it can help you, potentially stop taking as many NSAIDs, because we really don't want it to get to this point, because ulcers, they're really nasty things, very, very painful. Okay, moving on to the skin. So we know that the skin is affected by stress. So the temperature and our electrical conduction is affected by stress. And we can measure both temperature and electrical conductance. Electrical conductance, we can measure it by using a galvanometer. And this measure is called the galvanic skin response, the GSR. And it's sometimes referred to as the electrodermal response. And this is actually a major part of the lie detector test, which is pretty interesting. But we'll talk about that actually a little bit more in, I believe it's chapter 12 when we talk about biofeedback. Okay, moving on. And then stress can cause increased perspiration and vasoconstriction, and this can cause our skin to change color. So usually our skin may appear white or pale because, you know, that blood flow is, you know, becoming constricted, it's shunting off, and it's going towards more important organs or limbs that specifically need that blood flow and that oxygen. So we might appear a little white or a little pale due to stress. And then also, some of us might experience, you know, cold hands and feet. You know, the blood flow might be shunted away from the limbs in order to go to the core. So our heart and our lungs can be adequately supplied during that stress response. And everybody's a little bit different. Oh, something important that I want to mention. So stress and acne. So technically, there hasn't been a link between the two. And there's research that currently says that there isn't a link, but I have many students that you know, have taken this course in the past, and they are so shocked that there isn't a link between stress and acne. You know, I have students that say, you know, I get stressed out and I majorly break out all over my face. But unfortunately, researchers have not found a distinct link between the two. But you know, there's research coming out all the time, so we will see if anything comes out in the future. But at the moment, there technically isn't a distinct scientific link between stress and acne. Okay, so in conclusion, this physiological response will occur when you experience stress. And this response is going to occur if you experience a stressor that is physical or real, if you experience a stressor that is more mental or emotional, we will experience the same stress response if you experience homework stress, work stress, you know, physical stress from an accident. Our body is going to respond in the exact same way, which is really scary because we are putting ourselves through, you know, this physiological runaround, and we are exposing our body to all of these chemicals that were originally only to be meant for you know, times when we were fleeing from a very large animal back when we were cave people. But now this experience, this response is happening, you know, over a book report, for example. And we need to be really careful in how we handle our stress. We need to make sure that we are managing our stress, because if we don't, if we experience this for an extended period of time, we start to, you know, experience this chronic stress, you know, this long duration, low intensity type of stress. It will lead to illness or disease. And that is what we are going to talk about in more detail for lecture in week 3. Okay, so I am going to post an optional activity for any of you that are interested. It's a worksheet that I'm going to scan and post onto Canvas. And again, you don't have to do this. You don't have to turn it in. This is something that is just for you. And the reason why I posted this is just so some of you can bring awareness to your physiological symptoms, because until I mentioned some of the symptoms on the slide, some of you may have not had an idea that, you know, some of these symptoms were actually tied to stress. So if you're interested and you're really trying to learn how to manage your stress, I highly recommend that you fill out and complete this optional activity. Again, this is really important because if you know what symptoms to look out for, if you have identified which symptoms that you feel when you experience your stress response, you can try to bring in or use an intervention so we can stop that response from going further down the stress model. And if you have any questions, please, please, please don't hesitate to contact me. Send me an email or send me a message over Canvas. And that's the end of Chapter 2 lecture.